Hello, folks. So today we have a snow day with no school, or delayed opening. So I'm preparing your online lesson, which would have been today's class lesson, and it's going to be a review for the final exam. And so rather than giving you a hard copy practice exam, I will just go over each problem with, that'll be slightly different than the actual exam, but every type of problem that's on the exam as it will appear on the exam. So this lesson should help you prepare. So here we go. In this problem, we're going to find the derivative of y prime. We're going to need to use the chain rule. So we're going to take the derivative of 5 to the natural log of x squared with respect to the natural log of x squared, that's our outer function, times the derivative of the natural log of x squared with respect to x squared, times the derivative of x squared with respect to x, and there you can see our chain. Okay, so that's going to be the derivative of 5 to the natural log of x is 5 to the natural log of x times the natural log of 5. So that's 5. Let me go 5 to the natural log of x squared times the natural log of 5 times the derivative of the natural log of x squared is 1 over x squared times the derivative of x squared, which is 2x. So we put equal sign, and this is, I can put this over 1 and go ahead and let's grab red. This x cancels out one of these x's. Now I cannot multiply this 5 times this 2 because the 2 is a coefficient. The 5 is a base to an exponent. So we can move to the 2 to the front. We can say 2 over x times 5 to the natural log of x squared times the natural log of 5. Now this is one way to write our answer. I think I might clean that up a little bit and write this as 2, and the natural log of 5 is merely a constant. So I'm just going to write that like that, and this is over x times 5 to the natural log of x squared. There's a good way to write the answer because this, let's put a box around this. Okay, because the 2 times the natural log of 5 is a constant, and there's a denominator of x down here, and it's multiplied by a base of 5 raised to the natural log of x squared. There's our answer. In this problem, if a searchlight is shining on the ground, so let's imagine our searchlight, let me grab a purple. Let's say imagine our searchlight is coming from here, right, and it's shining down this way onto the ground right here. So it's like searching right here. And this is the pole right here. Actually, this is the pole right here. And this is the searchlight, and it's shining down onto the grass. And so if a searchlight is shining on the ground and moving across the grass, it's moving across the grass such that it moves at a horizontal velocity of 2 meters per second. It's moving 2 meters per second to the right. In 3 seconds, how far along the grass is the light if it started 4 meters from the base of the pole? Here's the base of the pole. So 2 seconds after it's 4 meters, how far away is it from its new base? So this is a related rates problem. And if we do the calculation with Pythagorean's theorem, where we say that a squared, let me get my marker here, we say a squared plus b squared equals c squared, we'll know that this length here, which is c, is 5. And that's a 3, 4, 5 triangle. In other words, 3 plus 9 plus 16, which is 25, and that's 5 squared. So we have this length here. So what we're looking for is we want to know what is our new length And we also want to know how fast the distance between the searchlight and the grass is growing. How fast is C increasing? So this is going to be a related rates problem. And so we could say, we could call this our A, length A, and this our B. And we could say that we know that A squared plus B squared is equal to C squared. We could also use x squared plus y squared equals z squared, but we can go with a, b, and c. Those are our variables. So we want to know what is the change with respect to time, because a and b and c can be functions of time. Let's see if I can move this over. I guess not. Okay. So so a is never changing. It's a constant. It's 3 meters per second. So I would say that its derivative is, with respect to a, is 2a times a prime, and that's the change in a with respect to time, which is 0, plus the derivative of b with respect to time is 2b, say times b prime, is equal to 2c times c prime. Now, the change in a with respect to time is 0, so this is going to equal 0. And then we have 2b, and b is 4. And b prime is the change in b with respect to time, which is 2 meters per second. And then we have 2 times c. C is 5. And this is what we're looking for. We're looking for c prime. How quickly is it growing? And so we can then say 2 times 4 is 8 times 2 is 16 is equal to 10 c prime. So c prime is equal to 16 divided by 10, or 8 divided by 5 meters per second. Okay, so this is the answer to our second question here. It is, say 5 goes into 8 once with 3 left over, so 3 3/5 meters per second. That's how quickly this distance is growing between the spotlight and the grass. And it also asked how far along the grass is the light if it started 4 meters from the base of its pole. So how far is it now? Well, that just becomes basic arithmetic. We know that it's how far does it grow at 2 meters per second. Well, if the velocity is 2 meters per second and we go for 2 seconds, we've gone 4 more meters, right? And if we started at 4 meters, then starting at 4 meters, we moved 4 more meters. So now we are 8 meters out, moving at a rate at that instant in time at 1 3/5 meters per second. Okay, so that's at 2 seconds, this is our rate of increase of the side. So this is the rate of increase of this C at 2 seconds. And this is its distance. In this problem, we're going to demonstrate the mean value theorem using a given function on a given interval. So let's start with our given function. Y is a function of x. And we'll make this very simple. It's x squared. And we're demonstrating the mean value theorem on an interval of 0 to 5. And what the mean value theorem says is that the mean value of the function is equal to the derivative for some point c between 0 and 5. So we'd say that there is some value c that is between, and it could equal 0 or 5, but somewhere in the interval from 0 to 5, such that f prime of c is equal to the mean value. So we have to first find the mean value, and the mean value is equal to f of 5 minus f of 0 over 5 minus 0. That's 25, 5 squared, minus 0 squared, over 5, which is 25 divided by 5, which is 5. So our mean value is 5. F prime of x is equal to 2x. And so there is some value c such that f prime of c, 2c, is equal to the mean value 5. If we divide both sides by 2, it's 5 over 2. So in fact, here we're showing that when c is 5 over 2, which is a value between 0 and 5, that f prime of 5 over 2 is equal to f of 5 minus f of 0 over 5 minus 0, which is the mean value.